We all ride a bike or drive a car almost every single day. We use it for going to work or going to school, or I should say almost every single day. But do you know that when you ride a bicycle or drive a car, the wheels of the bike or the car, they make two different kind of motion. One is linear motion and the other one is a circular motion. So in order to explain what I'm going to do, I'm going to consider a circle. So let's pretend this is the circle and this is the wheel of my bike, and this is the center C of the circle. Now, what I'm going to do, I am going to consider a point right here, like this point, and I'm going to consider that point as point P. Now, if I connect point C with point P, what will I get? I will get a radius R of the circle or the wheel. And I'm going to consider another point. Let me consider a different color. So let this point is my point Q, and this is also the radius. So CQ is also the radius. So CQ is also the radius. So I'm going to take CQ as R. So I can write CP is equal to CQ, and both are the radius of the wheel or the circle, and let that radius is R. Now let's consider this angle, and let this angle is angle theta. Now if I ask you to find the value of the arc, this arc PQ, can you find it? Sure. So let's consider PQ as an arc, and let the value of that arc is S, and the angle PCQ, or I can also say that angle QCP, is theta. Then we know the relation between the angle and the arc as angle is, we all know that angle is equal to arc over radius. Arc over radius. So if my angle is theta and my arc is S and radius is R, then we can write theta is equal to S over R. So as you can see, theta is equal to S over R. From here, what I'm going to do, I'm going to write this one as theta over 1 is equal to S over R. Now if I cross multiply, what will I do? I will multiply 1 with S and R with theta, and what will I get? I will get 1 times S is S, that is equal to theta times R is R times theta. And let this is our equation number 1. Right? Now let's consider we are going from this point, which is point T, to point A. And when we go from point T to point A, let this distance is S. And this distance is same as, like this S is same as this S. Then how do I find the linear velocity? So as you can see, when we are rotating the wheel, we are going straight. So basically the center of the circle is going, let me draw it here, the center of the circle is going this way, which is a linear motion, right? So the center of the circle is going in a linear motion. But if I consider any point, doesn't matter which point, if I consider a point at the circumference of the circle or the circumference of the wheel, then that will go in this direction. And this is basically my circular motion, right? Now, if I'm using the same wheel to travel this distance and this distance s is same as this s, like both these two s are the same, then we want to find the linear speed. So how do I find the linear speed? We know that speed is distance over time, right? So as we can see, we are considering the distance from t to a as s, and let small t is the time it takes to go from t to a. Then what will be my speed? My speed v will be s over t. Now I'm going to consider this linear speed v equals to s over t as my second equation. Now look at equation number 1. Equation number 1 is s is equal to theta times r and v is equal to s over t. So what I'm going to do, I'm going to substitute this s as theta times r. So I will write velocity v, which is linear velocity v, is equal to s, which is what? Theta times r over t. Let's simplify, and if I simplify, we write v is equal to theta over t times r. And just to let you know that theta over t is a quantity, we call it omega. So theta over t is omega. Let me write it here. Omega is theta over t. And then I have my radius r. This is equal to velocity v. So we can say that velocity v is equal to omega. This is my omega. O-M-E-G-A. We call it omega. So velocity v, this is my linear velocity, linear speed I should say. Linear speed is equal to, this is my angular speed, So linear speed is equal to angular speed times radius. Angular speed times radius. So linear speed is equal to angular speed times radius. So let's summarize this whole thing. The first thing that we have is linear velocity v is equal to s over t. This is our linear velocity or linear speed. So I will write linear speed, and my angular speed is omega is equal to theta over t. This is my angular speed, angular speed, and then we have our relation between linear and angular speed as linear speed is equal to angular speed times radius, which is basically this relation. So basically we have three different relationships: relation 1, relation 2, and relation 3. And this is how we will define the linear and the circular motion, and we can also define angular speed, linear speed, and what is the relation between angular and linear speed.